Section 2.4, solving multi-step inequalities. Section 2.2 and 2.3 were single-step inequalities. Section 2 was adding and subtracting. Section 3 was multiplying and dividing. In Section 4, we're going to expand that to multi-step. So we'll have two-step, we'll have three-step, we'll have inequalities with variables on both sides. We're kind of lumping them all together here in one video. All right, so we're going to start with multi-step inequalities, and there's really no notes per se to put on here. Just got some examples here for you. So directions say solve and graph. Number one, let's start with y over negative 6 plus 7 is less than 9. Okay, so y over negative 6 plus 7 is less than 9. Remember that when we're solving these inequalities, just like when we're solving equations, we need to undo the order of operations. So the first thing we need to undo here is adding 7, so we're going to do that by subtracting 7. Okay, so the 7's will go away. I'm left with y over negative 6 is less than, let's see, 9 minus 7 is 2. Okay, so now we can get rid of the negative 6. So y over negative 6 means y divided by negative 6, and to undo dividing, we're going to multiply. We're going to multiply both sides by negative 6. So those will cancel. I'm left with y, and then I'm working over here. 2 times negative 6 is negative 12. Now, I multiplied by a negative. This number right here is negative. So what that means is that my inequality sign is going to change direction. It's going from less than, and now it's greater than. Okay, so there's your answer. Y is greater than negative 12. If we want to graph, so we'll bring in a number line here, 1, 2, 3. So we'll have negative 12 in the middle, negative 11 to the right, negative 13 to the left. We are going to have an open circle at negative 12, and it says y is greater than negative 12, so that greater than is always out to the right. So y is greater than negative 12. There's your answer for number 1. Let's try another one here. Number 2. I've got 2v minus 4 is greater than or equal to 8. Okay? Again, this is a simple two-step equation. Going to get rid of the minus 4 first by adding 4, so plus 4 on both sides. So I'm going to have 2v, those go away, greater than or equal to 8 plus 4 is 12. Okay, so now I've just got one more step. Got to divide both sides by 2. v, 12 divided by 2 is 6. The question then becomes, do I flip my sign? What I divided by was not negative, it was a positive. So when you divide by a positive, your inequality sign does not change. It stays greater than or equal to in this case. Okay, so when we go and make our number line here, so we'll have 5, 6, 7. We are going to have a closed circle this time because we have the or equal to part. We have this part right here. Okay, so we're going to have a closed circle at 6, and then it says v is greater than 6. Greater than is always out to the right, so we're going to make our arrow or bold our number line and then make our arrow out to the right. Let's try another one here. Number 3. Number 3, 8 minus 9c is greater than or equal to negative 28. Okay, so anything not directly attached to the c, like this 8, needs to go away, and it's positive 8, so to make that 0, to make it go away, I need to subtract 8. If I add 8 here, what I'm going to be left with is 16, and that's not going to be any helpful. We need to make that 0. We need it to go away. So we need to subtract 8, and if we're going to subtract 8 on the left, we need to subtract 8 on the right. Okay, so the 8's will go away, but this negative sign right here does not. Okay, we're not getting rid of that negative 9, so it's going to be negative 9c is greater than or equal to negative 28 minus 8 is negative 36. We're going farther negative. Okay, now we need to get rid of the negative 9, so we're going to do that by dividing, because negative 9c means negative 9 times c. Negative 36 divided by negative 9. Okay, so the 9's will go away. We've got c. Negative 36 divided by negative 9, working right here. Negative divided by negative is a positive. 36 divided by 9 is 4. Now, I divided by a negative, this number right here, because it's negative. What it does, it flips the inequality sign. So instead of greater than or equal to, it's now less than or equal to. And then when we make our number line here, 2, 3 numbers, we got 3, we got 4, we got 5. We make an, this will be a closed circle. Closed circle again because we have the or equal to part right here. Okay, we have the or equal to part, so that means a closed circle, add our number, and this says c is less than. Less than is always to the left. C is less than is always to the left. So we got a closed circle at 4 with an arrow to the left. Let's try one more. Actually, I'm going to have to change pages. That's the bottom of the page. Number 4. All right, so we have 6 is greater than or equal to 5 minus v over 3. All right, very similar to the last one. We need to get rid of this 5 first, and it's positive 5, so we don't want to add 5. We want to subtract 5. We always look at the sign in front, not the one behind it, to see what we need to do. If this is positive, that needs to be negative. If this was negative, then we would be adding. Okay, so now we subtracted 5 on the right, which means we need to subtract 5 on the left. 6 minus 5, that's easy, that's 1. Greater than or equal to, the 5's go away, and I'm left with negative v over 3. Now, we could rewrite this as v over negative 3. Okay, and might make it a little easier to see what we need to do next. Okay, what we need to do next is we need to multiply, since we're dividing v originally. This says v divided by 3, so to undo dividing, we need to multiply. We're going to multiply both sides by negative 3 because we're dividing v by negative 3. So to undo dividing, we need to multiply. So those will cancel along with the negative. Negative 3 times 1 is negative 3. Like I said, the 3's cancel. I'm just left with v on the right-hand side. Now the question becomes, do I flip my inequality sign? And the answer here is yes. Okay, I'm multiplied by a negative. This number was negative, and with this one. If that number is negative, we need to flip our inequality sign. So negative 3 is less than or equal to v. Now the variable is on the right-hand side this time. It's over here. That's fine if you want to leave it there. Perfectly fine. If you want to rewrite it so the variable's on the left, you can certainly do that. We can put v, we can put negative 3. Now, we need to figure out which way the sign goes. If the original inequality sign, see how this is pointing towards the 3? When we rewrite our inequality down here, it still needs to point to the 3. It still needs to point at the original number it was pointing at the first time, back up here. Okay, so really it's v is greater than or equal to negative 3. So if we were going to make our number line here, 1, 2, 3, negative 4, negative 3, negative 2, we would have a closed circle, again, at negative 3. But since if we're looking down here, v is greater than negative 3, or if we read this one up here backwards, v is greater than or equal to negative 3. Either way, if you're not sure, you can always go put one of these 2 points back in. If I put negative 2 in for v, is negative 3 less than or equal to negative 2? Yes, it is. This would be a true statement. So that means I need to go this way. Okay, so I'm going to have an arrow pointing to the right. Again, if you rewrote it with the variable on the left, then it's easy. The inequality sign, see how it's kind of pointing towards the right, and then my arrow on my number line points out to the right. Okay, that's an easy way to remember it. Let's try something a little more complex now. Number 5. This one's going to have variables on both sides. 6x minus 5 is less than 2x plus 11. Okay, 6x minus 5 is less than 2x plus 11. Just like with equations, we need to make a decision. Do we want to put the variable on the left, or do we want to put the variable on the right? Either way is fine. We just need to decide. Knowing what we can do with the graphing here, if the variable's on the left, then our sign and our arrow match, I think it makes sense to take this 2x over and match it with the 6x. Okay, so I'm going to subtract 2x from both sides, minus 2x, because what that's going to do, that's going to put the variable on the left-hand side. So 6x minus 2x is 4x. Still have the minus 5. The 2x went away, still less than, and we have 11 over here. Now it's just like the first couple problems that we did. Okay, next step would be to get the numbers by itself, or get the numbers on the other side. So we're going to add 5 to both sides. So those go away. So 4x less than 11 plus 5 is 16. And then we have one last step. Divide both sides by 4. So the 4's cancel out. We got x is less than 16 divided by 4 is 4. Okay, and then we can graph our solution. 1, 2, 3, 3, 4, 5. This one is a open circle and open circle. An open circle at 4, this says x is less than 4, so less than is always out to the left. Less than always points left. Let's try another one here. Number 6. 5x minus 12 is less than or equal to 3x minus 4. Okay? Again, we need to decide, do we want to put the variable on the right, or do we want to put the variable on the left? I think left makes more sense just because of this, where if the variable is on the left, the sign and arrow point the same direction. So I'm going to do that. I'm going to make the 3x go over to the left-hand side. Okay? So 5x minus 3x is 2x. Still have minus 12. Still less than or equal to. The sign's never going to change when you add or subtract. 3x's are gone, and I'm left with negative 4. Okay? Next step, whoops, it's supposed to be 2 fingers moving the screen. Next step is to get the 12 to the other side. I'm going to do that by adding. So 2x, the 12s go away, still less than or equal to negative 4 plus 12. If I owe $4 and I give somebody 12, that means I should get $8 in change. So I've got 2x is less than or equal to 8. And then one last step here, got to divide both sides by 2. So the 2's go away. X, 8 divided by 2 is 4. My inequality sign does not change here because this number is a positive. We're not dividing by a negative. Okay, so it's going to be less than or equal to 4. And then when I go ahead and make my graph, I'm going to have 3, 4, 5. We'll have a closed circle at 4 this time because we have the or equal to piece in our inequality sign. And it says x is less than 4, so less than is always to the left. Okay, so there's a couple of examples with variables on both sides. The real key with those problems is you need to make sure you get the variable on one side. It doesn't matter which side, although I would maybe recommend the left because then you have that rule where if the variable's on the left, then the sign and the arrow match. All right, got a couple more examples here for you, something that might be a little different. Number 7, we've got 8b minus 3 is greater than 4 times the quantity 2b plus 3. All right, what I see here, the first thing we need to do, we should probably distribute here on the right-hand side. Okay, so the left-hand side is not going to change. 8b minus 3 greater than 4 times 2b is 8b. 4 times 3 is 12. Okay, so now we need to decide. We've got variables on both sides. Let's move the variable to the left. Okay, so I'm going to do that by subtracting 8b from both sides, but I see a problem. 8b minus 8b is 0. 8b minus 8b is 0. I'm out of variables. I've got negative 3 is greater than 12. Well, let's leave that one for now. We'll come back to it and discuss here in just a little bit. Number 8, last one. 2 times the quantity 5w minus 1 is less than or equal to 7 plus 10w. Okay, again, should probably do some distributing first. 2 times 5w is 10w. 2 times negative 1 is negative 2, less than or equal to 7 plus 10w. Okay, variables on both sides. Let's move them to the left. I'm going to subtract 10w from the right side, and if I'm going to subtract 10 from the right, I need to do the same thing on the left. But again, I'm running out of variables. I've got negative 2 is less than or equal to 7. Now, if this were equations, okay, and we got something like negative 2 equals 7. If you remember, if we had something that didn't match, this was no solution. But look here. We don't have equals. We have less than or equal to. We have an inequality. The question here, is this a true statement? Is negative 2 less than or equal to 7? The answer here is yes. Negative 2 is smaller than 7. So instead of having no solution because they don't match, this is an example of all real numbers or infinitely many solutions. You can plug any number in for the variable here and here, and you're going to get something that's a true statement. I'm not saying that they're going to match every time, but this is true. Negative 2 is less than or equal to 7. If you run out of variables, and that's the key, if you run out of variables and what you get is a true statement like negative 2 is less than or equal to 7, then you're going to have either all real numbers or infinitely many solutions. Let's go back to that other example. I ran out of variables, and again, I've got something that doesn't match, but we need to ask ourselves, is this a true statement? Is negative 3 greater than 12? Hopefully you realize that negative 3 is not greater than 12. This would be a false statement. So this would be more the example of like 0 equals 2 from our equations. Okay, if you get something where you run out of variables, and that's the key, you have to run out of variables. All I'm left with is negative 3 is greater than 12. If you get something that is a false statement, something that is not true, then your answer is no solution. Okay, or again the shorthand, 0 with a slash through it. Both examples here, I did not have something that was the same on both sides. Negative 3 is greater than 12, negative 2 is less than or equal to 7. The question you have to ask, just because they don't match, you have to ask yourself, is this a true statement? Because if it is a true statement, like number 8 down here, then your answer is still all real numbers or infinitely many solutions. Okay, just because they don't have the same number doesn't mean it can't be one of those two answers. The question has to be, is it a true statement? If it's true, then it's all real numbers are infinitely many solutions. If it's false, then it's no solution. So just be aware, you might get something that doesn't match, but it's still all real numbers or infinitely many solutions. Don't get in the thought process that, like here with equations, if it doesn't match, it's no solution. Well, they don't match, but we have all real numbers. You just need to be aware if it is a true statement or not.